Hey everyone, I'm Arsh and I work as a developer experience engineer at Okteto. I'm also a CNCF ambassador and a contributor to the Kubernetes project. I am joined today by Marom for this webinar. Marom, would you like to introduce yourself?
Yes, of course. Hey everyone, my name is Marom and I'm a software engineer at Sprkl. I'm from Israel and I'm working at Sprkl for like 1 year, something like that. Let's continue.
Awesome. Thanks for joining us today. And today we'll be taking a look at the problems which teams face when working on modern applications and see how Octeto and Sparkle can help solve them. So before we get started, I would like to catch everyone up on how did we get here and how these problems we are going to talk about they arise in the first place. So if you remember 5, 10 years ago, nobody was talking about microservices or these modern applications we now have. Everyone was coding monoliths. And curse monoliths all you want, a thing they were good at was making developers' lives easy. Because when you were working on an application, all you had to do was to get your dev environment up and running locally was just run a command or two, and the entire monolith would be up on your application and you could just code easily. But containers became the norm, and Docker popularized containers, and they led us to change how we architect our applications. They showed us that breaking down these monoliths into microservices is a much more scalable approach, and we started doing that. Now, this was all well and good for a year or two, but then people started to see the real potential of microservices. They did indeed offer seamless scalability, and Kubernetes came into the picture, and we started basically making more and more complex applications. And the thing with microservices is that if you have a couple of them, 2 or 3 microservices, they are easy to manage. But the complex modern applications we code these days become really tough. Because once you've broken down the monolith, you need to realize that these microservices still need to be put together, right? During development when you want to bring up your application, or because of just breaking down these microservices, it becomes tough to keep track of your overall application and get an idea of what is happening. So all of this change in how we architect our applications started causing problems for developers in how they work. So let's look at what some of these problems are. But before we do, I want to introduce you to the concept of what a dev loop is. Now, a dev loop is everything a developer goes through when they are working on an application before, let's say, like committing or pushing their code. So if they want to let's take an example. If they're working on a microservices based application and they want to work on the backend, just to work on that backend, they would need to bring up the front end maybe to see their changes. They would need to bring up the database, and then after they've done this, they can start writing code, and then then they need a way to get feedback from the code, see if that works, and all of this becomes encompasses the dev loop. This is a single developer's workflow when working on it. So this makes up the core of a developer's experience and is often the bottleneck for dev productivity. So, what problems this dev loop started facing because of containerization and the microservice architecture is that one, bringing your application up during development no longer was an easy task. Like we discussed before, like for monoliths, you could just run a single command and have the entire application up. This is no longer possible if your application consists of 10, 20 microservices. All of them might be hosted on different cloud providers or anywhere, basically. So just this bringing up the application phase significantly lengthened the inner dev loop and led to a bad developer experience. The second was that monoliths, when brought up on local machine, resembled what the production environment was like, because you were just running these monoliths on a server in production, right? But that's not true for microservices. Today, you could get your backend running on your local machine, but that would not replicate what is happening in production, where it's running in a container in a Kubernetes cluster and interacting with 10 different microservices, which might or might not be even on the cluster. So the second problem which we feel came into picture was developers started writing code in unrealistic environments which did not resemble production at all. Now, the problem with this is that it leads to bugs, and bugs which are not easy to catch because you cannot replicate them locally. Because if they were easily replicable locally, then they wouldn't occur in production in the first place, right? So these two start. These two main problems started coming from like microservices just because of our switch. To add to that, what happened was that the applications got so complex that understanding how your how the code you write for a particular microservice affects the overall application or a different microservice became very tough. You had no idea like how a code running in one part of your microservice was tracing back to some other code. Maybe like your backend executes something which leads to a database which communicates back, and all of this complicated architecture started leading to a frustrating developer experience because people just had a hard time keeping track of things because of the increasing complexity. So we have discussed problems in detail, but that's not what we want to do here. We want to look at what is a solution to these problems, what can be done to avoid this bottleneck and give a great developer experience. The solution is providing developers with modern tools. We feel that these problems originated because the advancement in tools which we gave to our developers did not keep pace with all the rapid advancement which happened on the production side with containers and Kubernetes. We kept using the same old tools we were using when coding the monoliths, and this new world of microservices required new tools to make developers job easy and provide them with a great dev experience. So we are going to talk about how Octeto and Sprkl help do that. Octeto is a platform for development experience automation. As an industry, we have always agreed that the dev environment should closely resemble production to minimize bugs and ship better quality software. So it makes sense in this era of where all our applications are deployed on Kubernetes that we leverage that during development as well. And leveraging Kubernetes in the cloud during development does not have to be a frustrating experience for developers. Developers should not be forced to learn Kubernetes and go to different cloud providers, set up a cluster, set up a database, and do all of that configuration when they want to write a code. We want developers to focus on what they do best, which is writing code, and uh, rid them of all these worries of setting up the infrastructure. Which is why one of the key things Octeto provides is cloud dev environments, which developers can launch in one click and get right to the code writing phase. So you see how this significantly shortens the inner dev loop, and developers do not have to run around and chase platform engineers to set up infrastructure for them. The other thing is that this also abstracts away the complexities of Kubernetes from developers because they don't have to deal with all the making like interacting with a cluster and doing all of the configuration which is needed. Now, you might say that tools like CI/CD exist, which give you a accurate accurate description of what will happen when you push code to production. But the problem with them is that they happen after you commit and push your code. And what we have been talking about in the dev loop, the inner dev loop, all of this is before you commit your code. This is where developers need like instant feedback as soon as they hit save. And we'll soon see this in a demo how Octeto enables that. As soon as you write a something, or if you as soon as you make a code change and hit save, you get feedback from that in a realistic environment. So these realistic environments help minimize bug and improve the quality of the software developers end up writing. I'm gonna let Marom talk about Sprkl and how Sprkl adds to this improved developer experience.
Thank you, Arsh. Sprkl is a personal observability platform which provides personalized feedback on your code changes while coding. With Sprkl, you will spend much less time on debugging, logging, and code review. Also, you will get end-to-end open telemetry and Jaeger-based traces. Let's continue to the demo. I think it will be the best. Okay. For the demonstration, I'm going to use a sample e-commerce store with few running services. We are going to start by running our development environment with the command Okteto deploy.
So what Octeto deploy does here is it takes all the manifests that you use in production, and it uses those to deploy to an actual Kubernetes cluster. This way, your application gets brought up in a similar fashion as you bring it in production. And this is what I was talking to you about in the previous slide, how the whole goal is to provide developers with an environment which is realistic and which exactly replicates production.
Okay, let's see that our environment is up and running. Okay, let's continue. Now I'm going to run Sparkle Kubernetes apply and choose which services I want to instrument. We have two levels of instrumentation. The code level instrumentation, which provides instrumentation about code changes, and infra level instrumentation, which provides instrumentation of infrastructure and libraries.
So as you'll soon see that once we have deployed this application, this sample application is supposed to resemble the kind of applications you code today, where it's not just a single microservice. There are different microservices interacting with each other. Manum, could you show like the UI and what the application is?
Can you repeat, please?
Can you show what the application is like while this happens?
Yes, of course. You can see that you have an e-commerce store. You can make orders, everything here. But first, let's apply the Sparkle operator so we can see the instrumentation. Here we choose which services we want to instrument at infra level. So as you can see, I chose all of them. And then you choose which services you want to instrument at code level. So I also chose everything. This is the repository, the path of the repository. And here I choose the recipe. Recipe means which code changes I want to instrument and get telemetry about. Here I will choose uncommitted, so it will instrument only the uncommitted changes that I made. To apply the instrumentation, we need to restart all the pods. Those are all our pods, and now I'm going to restart everything. And then we'll see the application running, and we'll see the environment up.
So if you go back and see that the application was up and running, and this is not running locally on the machine, because when Marom ran Octeto deployed this on the Kubernetes cluster. And what is happening is that there is port forwarding. So ports which were opened on that cluster have also been opened back on the local machine, and you can access them.
Yes. Okay. So now let's make a sample order to see global traces. Now you can see in the Sparkle dashboard insights about your code. As you can see, we don't have personal view, which means we don't have any uncommitted changes that got instrumented. We only can see global view. We can see our API calls, everything that happened behind the system, between the services themselves and outside of the services. Here we can see the trace, which shows us what happened in this specific part of the application. And now let's show what happened when you make a code change. So for that, we have Octeto development mode. Arsh, would you like to explain about the development mode?
Yep. So this is just about bringing your application up and providing developers with a way to get started and get to the code writing phase easily. But once they are at the code writing phase, Octeto enables you to just run a single command, which Marom is just going to do right now. Octeto up. And what this command does is it replaces it lists first of all the microservices which you want to develop in your application. And in this case, we're going to choose the microservice where we are going to make our code change and hit enter. And Maram, could you do that?
Yes, of course. Here in my
Yep.
configuration of Okteto, I chose to create development node only for order service and metric service. So now let's
So,
put orders in development mode. And in another
so
terminal, we will put metrics in development mode.
So you see like how powerful this is. Like regardless of how many microservices make up your application, you can choose to work on them simultaneously, and you as a developer do not have to do any configuration at all. So what happens when you choose a development like the run Octeto for a particular microservice is that the application which was deployed in a Kubernetes cluster, it has the container running in it, and that container gets replaced with a development container. And what's special about this development container is that it synchronizes all the code you write locally with the code which gets run in the cluster. So now you see like it is synchronizing the files. So once that happens, then anything you code locally, whatever, let's say you add a button on the front end, you hit save, you'll see that code will get transferred to the cluster, and you'll get feedback from your changes instantly. And this is why we feel like the inner loop gets shortened, because developers no longer have to commit their changes and push them and rely on CI/CD to get a glimpse of what their code change looks like. They can do it instantly and be sure that this is what they'll get when they push to production. So we should now have access to a terminal inside this dev container, which Marom is now showing.
Yes.
And let's write some code, Marom.
Okay. Before that, I want to show that we put both of the services in development mode, but it was seamless for us. The application is
Yes.
still running like before,
Could
and
you increase the size on the browser? I think the text was a little small. Yeah.
okay. Now I'll make some code changes to see traces about the application and about the changes I'm about to make. The first change I'm going to do is in the metric service. I'm going to open a new endpoint. As you can see here, I have a commented code. So now when there will going to be a put request to slash update metrics on the metric service, we expect to see some traces about it and some insights about it. So now let's save. And as you can see, the node application restarted because the code change I just made. It happened instantly, and now the application is running, but with my new changes.
And you did not have to commit these changes or wait for CI
No,
processes to see how that happens. It just like worked. So I think this is like the advantage you get from shortening your inner dev loop and not relying on things like CI/CD and staging environments. And now this is not to say that they are not useful; they have their place. But what the problem we are trying to solve here is making development just a good experience for developers instead of them having to wait minutes or hours to get feedback from their code.
okay. So now the second change I'm going to make is to make a request to this endpoint that I just opened, and I'm going to do this in the order service. So as you can see, I have the comment here, and now when there's going to be an order to in our e-commerce shop, we are going to make another request to slash update metrics on the metric service. So now let's save the code and see that the node application is restarted. You can see that it happened, and which means that now the services that are running with the newest code that we just created, and we are going to have traces about the code that is going to run. So now let's make another example order in the shop and see the personal traces. As you can see now in the dashboard, we have personal view, which shows us all the interactions and all the security things about the code we just created. Here you can see the, the put request to the new endpoint that I just created. And when you push the slot icon, you will be directed to the exact line of code where this request made from. Also, you can see the trace that related to this line of code, and you can see what caused this line to run. Here we can see that there was an order on the order service, and this caused the put request to slash metrics. That's
Yep,
it.
I think it is like all of these things when like these like tools which people use to analyze their applications. When people do not develop in realistic environments, they end up doing this in production and then debugging their applications, which I feel like is leads to problems, and that is why we feel that you should just empower your developers with tools like this so that they can do all of these uh, traces and check their application during development and be sure that this is what they're getting when they go to production.
Okay. I think that this is about the demo. If you don't have something to add, Ash, I think we can move to the Q&A.
Cool. So we hope that you found this demo useful, and it highlighted the problems we had talked about and how Sparkle and Octeto just seamlessly work together to give an experience to your developers where they do not have to deal with all these headaches of working with microservices. We will now take questions if there are any in the chat. I think I see a question. Does Octeto work with any cluster? And yep, it does not have to be like any cloud provider. You could use any cluster. And there is a self-hosted model with Octeto. If you go to octeto.com, you can see about that, where you can bring your own Kubernetes cluster and install all the Octeto-related dependencies on that and use that. But we also have a SaaS offering which you can try if you don't want to use your own cluster. I don't think we have any questions, so I think we can end it. But thanks for joining. And as next steps, we would invite you to try out the application which we were using in this demo. We'll send you the links, anyone who is registered for the webinar, and you should have that application. Try it out, use Octeto, use Sparkle, use them together, and let us know if you face any hiccups or in the like when trying out the applications. You can reach out to Sparkle on support@sparkle.dev, or you could reach out to us on our community form at community.octeto.com. But basically try out the two tools together and see how they improve your workflow. And that was it, and thanks for joining.
Thank you very much.